Agents of Change, the next AI revolution.
I'll start from the very beginning. Probably you've heard about agents and your brain go to the Matrix, no? Agent Smith. But in reality, as I said, it's before the Matrix, or rather around that time, actually. An agent is a person or entity that acts on behalf of another to produce a specific task. So I think you should think about them as our personal digital assistants, no? That they're there to help us in each and every task, okay? The nice thing about agents is that they have some specific properties. In fact, all agents are programs, but not all programs are agents. Okay, why? Because even though an agent is a software entity, it has a number of properties that you don't normally find in software programs. So it has autonomy, it means it can decide on its own. Mobility, it can move from one server to the other, it doesn't need to stay and run in one server. Communication, so agents can communicate with humans, but also with other agents. So that's a feature. Cooperate, they get together to solve particular tasks. Proactivity and reactivity, so beforehand and after, and also the learning aspect through, of course, machine learning. So those are what distinguishes an agent from a normal person. Now, of course, how did everything begin? Well, it started very long ago. I urge you to look at a paper of Vannevar Bush, 1945. So Vannevar Bush was the director of Project Manhattan, the one that developed the atomic bomb. And in his paper, he came up with this idea of creating this special desk whereby you have your documents on this desk and somebody else can see those documents and maybe share them with other people. You see where I'm going? He was foreseeing the World Wide Web of today. Of course, it took another 40 years for the World Wide Web to become a reality, and that's what Sir Tim Berners-Lee came about. So he says, listen, let's create this web, this interconnected web of documents, where we can share documents, people annotate on different documents, and basically, share the information together. However, the problem was that this web was created, as you know, it was very successful, but there was a tiny glitch in how it evolved. Basically, the web which we use till today is very much for human consumption. No? So it has images, it has videos, it has flashy animations, okay? But what about agents or programs? Think about them. They only understand ones and zeros, numbers. So for them, it's very difficult to understand the web. And that is why, Tim Berners-Lee said, listen, this is not exactly what I wanted out of the World Wide Web. And in fact, some years later, he came up with a different idea. He said, listen, how can we create a better web? Something which he called a fuller realization of the web, one which is understandable by both the humans, but also by the software. And that led to the creation of the semantic web. So the semantic web, back then, it was thought to be Web 2.0. Eventually, it didn't become Web 2.0, it became Web 3.0. But at the time, what happened was that in the 2000s, as you know, there was the dot-com bubble. And the dot-com bubble brought about the new kind of web, the social web. So the web of LinkedIn, the web of Facebook, etc., etc. But what are the differences between them? So if we go to the original web is very much consumption-based, no? I go over there and I consume content. I consume images, I consume text, I consume videos, okay? And if I want to contribute, I need to be a programmer, which most people are not. The social web is very different because in the social web we have our posts, no? And even if I'm not a programmer, I can post whatever I want. I can post images, I can post videos, whatever. So now there is mass contribution. You don't need to be a programmer to contribute to the web. But then there's the semantic web, or the Web 3.0, and that's the intelligent web, where you have agents working on the web, understanding what's happening, but also creating content on that web as well. However, unfortunately, the semantic web did not work. It died a very natural death. First of all, it was too complicated. I did a lot of work 20 years ago on that. It was hard to grow. It was an idea ahead of its time. No immediate benefits, so the businesses didn't really see the need for the semantic web. There were very big trust issues, and we still have trust issues. I mean, how can you trust a program with your information, with your money, with your bank account? And of course, the language, natural language, like the one we use, is still very complex, and it's difficult to understand. So the semantic web back then was an idea ahead of its time, and that's why it didn't, succeed. Now in your head, play that little voice of SpongeBob, no? 20 years later. And we're back to today now, okay? And today there's something which is very interesting, which are the age of transformers. Not those transformers, all right? I'm talking about the transformer architecture of ChatGPT and all the other large language models, okay? So a few years back, we saw the rise of these transformer architectures that practically revolutionized how we do AI. Like when I was a student, I was in the natural language processing department, so there were lots of PhDs working on different tasks. With large language models, a lot of those tasks got wiped away suddenly, okay? Of course, they're not perfect, but they're pretty good at what they do. So this is a very big revolution. Sometimes we hear about, ChatGPT, but that's just one of them. There are loads of them. So you have GPT-4, of course, Claude, which is a very powerful model. We use a lot for programming. There's Llama by Meta. Llama is also a very powerful model, which we use extensively as well. There's Gemini as well by Google. So as you can see, it's a massive tree of large language models. And today, a lot of the development is happening in that space over there. Of course, you might ask, why are they called transformers? For a very simple reason, because they transform, no? They transform one sentence in English to one sentence in French. They transform a big chunk of text into a small chunk of text, which is summarization. They transform an utterance into a reply, so you have the chatbot. They transform a question into an answer, so you have question answering. So as you can see, if you can formulate your problem as a transformation problem, then you can use large language models. Okay, and this leads us to something that's quite cool in my opinion, called Smallville. So Smallville, which by the way has nothing to do with Spider-Man, okay, it's a small village, a virtual village made up of tiny entities. But the nice thing about these entities is that each one of those entities has a large language model inside it, and it can decide what to do as an entity. So for example, if you look at the case study, one of them decided that he would like to run for mayor of Smallville. So he was going around campaigning and telling people to vote for him. Another one, for example, decided to launch a Valentine's Day party. All right, so she was going around giving invites, etc. But the cool thing is that all of them are individual intelligent agents. They were not programmed to do that, but given the context in which they were working, they were taking autonomous decisions of how to operate in that context. Now, Smartville was interesting because it was the first of its kind. It was the first that showed that using large language models, now we can have a community of agents, okay? And of course, the question is, what's next with this community of agents? And in fact, this is a little bit what's next of those agents. I don't know if it's playing. Okay, now it's playing, all right? So that is ChatDev Studio, all right? So what is that? That is practically a company made up of intelligent agents. And in that company, you have the CEO, you have the designers, you have the programmers, you have the HR, you have the graphics artist, whatever, all right? And what you see on the right of your screen is these agents communicating with each other. And soon you'll see that some of them will actually start creating the code as well. So they have a task, and they are actually executing that task. You'll see it in a second. You see that's the code being created. And then there are people evaluating that code, blah, blah, blah. So you see where things are going. Essentially, we will have an army of these agents. Of course, they will be specialized on particular tasks, and they will provide us with different services, okay? So we're moving away from the generic large language models like ChatGPT. I mean, they will still be there, but we'll start seeing these specialized now large language models, and we can ask them to do particular tasks for us. And in fact, I think this will lead us to what I like to call the agent economy. So, as I said, today large language models are very important, but in a few months and years' time, we'll see agents that will become even more important. Of course, they will use large language models as their basis, but not only. Because remember, one of the problems with large language models is the hallucination aspect. So they tend to invent things, no? So we will still use large language models, but probably with some layers of logic attached to them. And in fact, I have a short video of two things. Actually, this is Claude. So Claude is another large language model, and this video was released two weeks ago. And over here you will see Claude as a large language model taking control of a machine now, okay? So I'm telling Claude to do a particular task, and Claude will actually do that task by taking control over my machine. I'll tell you what's happening. So he's giving it the task. Now Claude is the model on the left, which you'll see in a second. And then what is going to happen is that it will actually control the mouse, go on the different aspects of the spreadsheet or of the browser, go for specific things. So this is the prompt that's given to Claude. All right, please fill out the vendor request form, all right, using data from either vendor or search portal tables in window 1. List and verify each field as you complete the task. Okay, so it took a screenshot of the window, and it starts looking in the window for the information. Now what happens is that Claude did not find that information, so it actually switched the tab, and it will now search inside that search engine over there. It will, as you can see, the control of the mouse and everything is being controlled by Claude, all right? So it gathers all the information from the search engine, and now it will copy and paste that information inside the form, one by one. So you see it has knowledge of which pieces of items it can copy, where they should be copied, etc., etc. Finally, once it fills up the form, then it will actually submit that form for submission. But as you see, the entire process was automated with this large language model. Now, some of you might remember something called robotic process automation, no? Now, this practically killed robotic process automation overnight, okay? It's still not widely available, but once it becomes available, it will take over very easily. The other video, which I can't show you because of the sound, all right? It's the one released by ChatGPT, OpenAI, sorry, when they released GPT-4 around January of this year. So what you're seeing there is he has two agents. One of them is his personal agent. The other is the agent of a company that takes the replacement phone. So I bought a mobile device and I need to return it because it's broken. So it's asking its agent to actually contact the other agent and negotiate the transaction. So it's asking information about the status of the phone, whether the phone was broken or whether it fell on the floor, and it also relates the procedure to return the mobile phone. I'm sorry you can't hear the sound, but I suggest you go on YouTube and you'll find the whole video. It's quite impressive. But what will happen is that, eventually we'll have one of these agents in our pocket, we will talk to the agent, and then the agent will go negotiate with other agents and take particular actions. Now, these actions could be varied. It could be, for example, the classic case I like to bring is imagine you're booking a holiday, no? What would happen? So the agent would go to the airline, it would go to the hotels, it would go to the taxi service, to the restaurants, and then it would gather a program for you. You would review that program, change it if you don't like it. If you give it the go-ahead, it would go practically get the money from your bank account, with your permission, of course, and book everything for you. Okay, so this is just one example of agents. Another is, for example, in the health industry. You need to book an appointment. You need to find the right doctor. You need to find the right timing with your calendar. So this is what agents will be doing in the next few months. I'll leave you with these three quotes from people I'm sure you know. Agents are not only going to change how everyone interacts with computers, they're also going to upend software industry, bringing about the biggest revolution in computing science since we went from typing commands to tapping on icons. As you can see, it will be a very massive change. I'm sure we still haven't understood what it will entail, but that's the direction we're going. Agents will become the primary way we interact with computers in the future. This will be able to understand our needs and preferences and proactively help us with tasks and decision making. Remember, the agent will know us. It will know our preferences. It will learn what we like and what we don't like. And more than that, something interesting in this quote is that we can interact with it using natural languages. So today there are a lot of people that still find it hard to communicate with a computer, but using natural language, it will become extremely easy to speak to a computer. AI agents will become our digital assistants, helping us navigate the complexities of the modern world. They will make our lives easier and more efficient, all right? Today, you have your personal assistant, no? In a few days' time or months' time, you will have your agents in your pocket taking care of whatever you need. That was all. Thank you very much, and I don't know if there's time for questions, but if not, there's the panel.